Hello and welcome back to Nunley Math. I'm your host, Aaron Nunley. I want to thank you for taking the time to join us. Appreciate you watching and following along as we work our way through Algebra 1. Specifically, right now, we are talking about inequalities. We've learned about how to graph inequalities, how to solve some inequalities. We're kind of reaching the end of this unit. We actually have this lesson and one more coming up. Just to give you a quick preview, we are going to be talking about functions next. Functions is actually a very, very cool unit. I'm excited to get started on it, but we still have one or two little odds and ends to clean up with regard to inequalities. So let's get started, shall we? I want you to think about something for me. If I asked you to graph x is greater than 5, could you graph that on a number line? Hopefully you realize that this x is greater than -5 says, what are all the numbers that are larger or have a greater value than 5? Well, certainly 5 does not have a greater value than itself, so we use an open circle, but everything to the right of 5 on the number line is greater than 5. What if I asked you to graph x is less than or equal to 10? Could you graph that one? Hopefully you were thinking something along these lines. We have a closed circle at 10 because although 10 is not less than 10, 10 is equal to 10 and does meet this condition. And the numbers that are smaller or of less value than 10 are over here on the left of the number line. Now we should have been able to do that based on some things that we learned in previous units. But I want to look at these two inequalities together. Notice that if I were to draw some vertical lines through the dots or the endpoints of these two inequalities, I've essentially divided my number line into three sections, 1, 2, and 3. Over here on the far right, I have those numbers that are larger than 5, but are not less than or equal to 10. 11 is bigger than 5, but 11 is not less than 10. Over here on the far left, I have those values that are less than 10, but are not bigger than 5. For example, 0. 0 has less value than 10, but 0 is not greater than 5. And then I have this third section in the middle, this overlapping section, those numbers that are both larger or greater than 5 and also less than or equal to 10. For example, a 7. 7 is greater than 5 and 7 is less than or equal to 10. 7 is interesting because it doesn't just meet one of the conditions or the condition set by one of the inequalities, it meets the condition set by both inequalities. Notice that that 7 falls in this little section here where we see overlap in our number lines. Now I mentioned that for a reason. When we talk about compound inequalities, they come in two types. The first type involves using this word and. And says what numbers meet not only the condition of this first inequality, but also the condition of the second inequality. In other words, if I look at all the numbers that are larger than 5, and I look at all the numbers that are less than or equal to 10, are there any numbers where there is overlap, or are there any numbers which fit into both categories? Now up here we just said there were. All those numbers that are in this middle section or this overlapping section meet both conditions. 6 is greater than 5 and 6 is less than or equal to 10. We already talked about 7. Let's talk about 8. 8 is greater than 5 and 8 is less than or equal to 10. 9 is greater than 5 and 9 is less than or equal to 10. 10 is greater than 5 and 10 is less than or equal to 10. And of course there's an infinite number of fractional or decimal values that also fit in here as well. We can take those two overlapping sections of the number line or of our graphs and we can combine them to identify what we refer to as the conjunction of those two inequalities. The conjunction. In other words, This graph here represents the overlap of these two separate inequalities. We refer to this as a conjunction. A conjunction is formed when two statements are connected using the word and. The solutions to a conjunction must be true in both sentences. The solution set to a conjunction is the intersection or the overlap of the solution sets of the individual statements. Anytime we have a conjunction or use this word and, we're only looking at those values that are true in both inequalities. Let's try a few of these on our own. I'd recommend pausing the video for just a second and trying these independently and then restarting the video. I'd probably do that for each of these and then restart the video in between to check yourself as you go. I, of course, am going to keep right on going because I'm going to assume you're doing that on your own time. I'm also going to go ahead and get my little marker here ready so I can make myself a few notes. If I'm looking for things that are greater than -3, greater than -3 is going to be an open circle with an arrow to the right. If I'm looking at things that are smaller than 7, I'm looking for things that start here with an open circle and go this direction. Since I'm using the word and I have a conjunction, I'm looking for the overlap of those two sections. Any idea what the answer here would look like? It's going to look like that green section there. Let's see, I have an eraser here. Yeah. It's going to look like that green section right there. Is that what you got? Why don't you try the second one? X is less than -1. That's an open circle here. Less than is over here. X is greater than -5 is going to be over here and here. We're looking for the values that make both those statements true, or the overlap. That's the section in between here and here. Notice I have those values. Let's go through and erase that ink as well. How about x is greater than or equal to -7? Greater than or equal to means we would include the -7. Greater than is going to be the numbers here to the right. X is less than or equal to +8. +8's way over here. I'm going to color that in. Arrow this direction. Any idea what the overlap would look like? How about that? Notice only those sections where the lines overlap, because and means it has to meet both conditions. Now I did put this on here. This is slightly different for you. This is -5 is less than x, which is less than 1. This is a shortcut way of saying -5 is less than x, and x is less than 1. It's just an abbreviation way of writing. Can you figure out which values meet those conditions? Hopefully you came up with that. Notice the open circles because -5 is not less than itself and 1 is not less than itself. Notice down here, this one is written backwards as well. Don't forget that when you write those backwards, it's much easier if you turn it around. If -2 is greater than or equal to x, that means x is less than or equal to -2, and x is greater than or equal to 5. Now I really like this particular example because if I have x is less than or equal to -2, I'm looking at these values. If I have x is greater than or equal to 5, I'm looking at these values. What values work in both or make both statements true? There's the first one. There's the second one. I can even delete my ink from that. Where's the overlap? Well, there is no overlap. They don't overlap at all. Remember, each of these has their own set of solutions. The word and means we're looking for the values that work in both. Don't forget that if they don't overlap, you need to erase your work so that we can see it's a blank number line. This is how you would present that. You would just say no solution with nothing drawn on your graph. Hopefully that makes perfect sense. Let me give you the other type of compound inequality. If I were to graph x is greater than 5, it would look something like this. If I were to graph x is less than or equal to 1, it would look like something like this. Notice that everything in the first number line is over here on the right, everything in the second number line is over here on the left, and notice once again we have this third section in the middle. Notice over here we have things that are greater than 5, but not less than or equal to 1. Over here we have things that are less than or equal to 1, but are not greater than 5. Notice that in the middle we have things that are not greater than 5 or less than or equal to 10. The things in the middle here meet neither condition. They meet neither condition. Remember before when we had that overlap, we were looking at things that meet both conditions. In this case, there is no overlap. The things on the right meet one condition, the things on the left meet the other condition, the things in the middle meet neither condition. So if I ask you to give me the values that meet the statement or meet the conditions of the statement x is greater than 5 or x is less than or equal to 1. I'm doing something different than I did on my conjunctions earlier. This is actually referred to as a disjunction. A disjunction. A disjunction says compare using the word or. And when we're comparing using the word or, we're not looking for the items that meet both conditions, but we're looking for the items that meet either one or the other. Notice this blue line up here are things that are greater than 5. The purple are the things that are less than or equal to 1. As long as my value falls in either data set, it is considered to be acceptable. So when I bring this down, I'm going to have everything from my blue line. I'm also going to have everything from my purple line. The solution to my disjunction is the graph you see in front of you. Both of these green lines, as long as we meet one condition or the other, it is deemed to be acceptable. Here's the definition of disjunction in a more formal setting. A disjunction is formed when two statements are connected using the word or. The solutions to a disjunction must be true in one, the other, or both is fine. The solution set to a conjunction is the combining or union of the solution sets of the individual statements. Now, I will tell you, most people find conjunctions to be very easy. Most people find disjunctions to be very easy. The tricky part is keeping straight when you're doing one and when you're doing the other. When we're using the word and, we're looking for the overlap. When we use the word or, we're taking the combination or we're combining everything from both solution sets. A little bit tricky. Let's try some disjunction examples. If x is less than or equal to -1, what would that look like? Here again, you're probably going to want to pause and try this and then come back and check it, but that's okay. Less than -1. If I'm looking for things that are greater than 4, they're going to look like this. Notice there is no overlap, but overlap is unnecessary because we're using the word or. As long as our value fits in one of the arrows or the other, it's acceptable. And so our solution is both of these. Let's try the next one. -3 is less than or equal to x. Don't forget that if -3 is less than x, sorry, not equal to, if -3 is less than x, x is greater than -3. You have that graph. If you have x is less than -5, you have that graph. Notice there is no overlap, but overlap is unnecessary. As long as a number meets one of the conditions or the other, we would include it. So this is our solution. How about the next one? X is greater than 2, or x is less than or equal to 5. Well, greater than 2 looks like this. Less than or equal to 5 looks like this. Now we have an interesting situation because we still have this division into 3 sections. The things over here are the things that are greater than 2. The things that are over here are less than or equal to 5. And the things in the middle meet both conditions. When this happens, it's very important that we keep in mind that we are using the word or and not the word and. If we were using the word and, we would be looking at this section right here in the middle where they overlap. That is not the case. When we're using the word or, as long as they meet one condition or the other condition, or they could meet both conditions, then they're deemed acceptable. So if I were to erase all of this, what do you think that's going to look like? What values meet one condition or the other? All of them do. Every single number is either bigger than 2 or less than 5. Now, some of them meet both conditions, and that's okay. Usually the question arises around the number 2, because when we draw these arrows independently or separately, you'll notice that 2 has an open circle because 2 is not greater than 2. 2 does not meet this condition. However, 2 does in fact meet this condition. 2 is less than or equal to 5. You'll notice that when I drew this second arrow, let me back that up just a hair. When I drew that second arrow, the arrow that goes to the left, starting at this dot, actually passes through that open circle. I was deliberate about making sure that you could see that, so you can see that even though 2 does not meet this condition, it does meet this condition and is therefore part of our solution. I would put a little star next to this one. This is the one that people tend to find the trickiest. Make a little note that you need to go back and take a second look at that one. How about this one? X is greater than 3 or X is less than 3. Any idea what that's going to look like? By the way, notice that I did go back and list this as all real numbers. I almost forgot to mention that. Notice that X is greater than 3. You have an open circle at 3 arrow to the right. X is less than 3. You have an open circle arrow to the left. Notice that every value is included except for the 3. 3 is not bigger than 3, and 3 is not smaller than 3. Therefore, we have to leave it out of both. This actually is our solution. By the way, you could also describe this as x being not equal to 3. It's a much shorter way to say that x can be anything except 3. Last one, x is greater than 4 or x is greater than 8. There's x is greater than 4. There's x is greater than 8. What's that going to look like when you put those two together? Notice that x is greater than 8 does have that open circle, but notice that we've drawn a line through it. That's because even though 8 does not meet this condition here, 8 is greater than 4. 8 is greater than 4. As long as it meets one of the condition, it's considered acceptable. And so we color that whole thing in. Notice that 4 doesn't meet either condition, so we leave it open. The third thing we need to make sure we talk about is solving compound inequalities. Notice that I have -3 is less than or equal to x plus 5, which is less than or equal to 10. These are actually not overly complex to solve, as long as we remember that this is the compound inequality and. This is an and. I can solve this pretty easily, just like we would solve any other inequality. In order to get rid of plus 5, I have to subtract it. But whatever I do to one side of the inequality, I have to do the other, or in this case, I have to do in all 3 sections. That becomes -8 is less than or equal to x, which is less than or equal to 10. Remember, this is an and statement. -8 is less than or equal to x, which is less than or equal to 10. Or -8 is less than or equal to x, and x is less than or equal to 10. The other way I say this is between. X is between -8 and 10. We have the equal sign, so it is inclusive. Looks like this. You might want to pause and try example 2 on your own. Works much the same way. I'm going to assume you've already done that. I have to get x by itself, so I'm going to get rid of that plus 7 first. Do it on all 3 sections. Then I have to get rid of times -3 using division. Don't forget that when you multiply or divide by a negative in an inequality, you have to flip the signs. In this case, 5 is greater than or equal to x, which is greater than or equal to negative 3 1/3. Or many people would prefer to have the smallest value on the left. So instead of 5 being greater than x and x being greater than negative 3 1/3, yes, I do know I need those equal signs in there. A lot of us will reverse that and put the smallest on the left. Negative 3 1/3 is less than or equal to x, which is less than or equal to 5. And because we have those equal signs there, we do need to color these in. Last example over here, I'm using the word or. Ors cannot be written using that abbreviated technique. You have to list those separately. It's actually pretty easy. You just solve each of them separately and then at the end stick your word or in. So I'm going to solve this inequality on the left, add 4 to both sides, divide both sides by negative 3. Don't forget, when you divide by a negative, you have to flip your sign. If you don't remember why that is, you'll want to go back and watch your first inequalities, solving inequalities video. Over here on the right, to get rid of the minus 6, we do plus 6 on both sides, so x is greater than 7. And as I mentioned, don't forget to drop the word or. That's your solution. X is less than or equal to negative 4, or less than negative 4. X is greater than 7. And there is your solution. One last thing. We sometimes think about, have to think about where compound inequalities come from. Here's an example in real life where you might see something like this. Normal blood pressure while your heart is contracting, that's your systolic blood pressure, is between 120 and 140. We could actually express this as a compound inequality. Since we're using that between language, we know two things have to be true. We have to be higher than 120, and we have to be lower than 140. So our blood pressure must be greater than or equal to 120, and also our blood pressure must be less than or equal to 140. Or you could use your between language for that. Is this a conjunction or a disjunction? Since it has to meet both conditions, we would use the word and. This would be considered a conjunction. The opposite of this can actually be written as a compound inequality as well. You should be concerned about your blood pressure if it is above 140. We call that high blood pressure. Or if it's below 90, which is low blood pressure. We could list this as a compound inequality as well. Now, just so you know that I'm aware, if your blood pressure is between 90 and 100, because I noticed there's some discrepancy between the numbers here and down here, just keep in mind that if your blood pressure is that low, it's usually considered to be slightly low, which is associated with good health, not problems. But if your blood pressure gets below this 90, that's when they start to worry that you actually have some blood pressure problems. So just throwing that out there because I knew the discrepancy in the numbers would throw people off. Notice that you have two different problems. If you are above 140, it's a problem. Or if you are below 90, it's a problem. You don't have to have both of those things in order for it to be a problem for you. As long as one of those conditions is showing up, your doctor is going to be very, very concerned. So we could write that as your blood pressure is more than, greater than, or equal to 140, or your blood pressure is less than or equal to 90. Either of these represents a problem. In order to be healthy, both those conditions must be met. You need to be above 120 and below 140. But in order for you to have be having blood pressure difficulties, either of the conditions can cause problems. That is, of course, a disjunction because only one of them must be true. That's basically all we've got for today. I do appreciate you taking the time to listen. As always, if this has been helpful to you, please make sure you leave us a comment in the comments section. Take the time to like and subscribe and turn on your notifications so you'll know when we're covering something new. Once again, our goal is to cover all of Algebra 1 this year, so we'll have this as a resource long term. Thank you so much for your time and your effort. Best wishes to all of you. Take care.